Hi everyone, for today's lesson we are going to learn how to solve quadratic equations using the factoring method whenever a does not equal 1. Our learning objectives for today is for you to be able to say I can solve quadratic equations by factoring. I can convert a quadratic function into standard form, from standard form to intercept form. I can find the zeros of a quadratic function that is in standard form by rewriting it in intercept form. And I can use the quadratic functions to solve real-world problems. Those revenue questions are coming back again in this lesson, so that should be a lot of fun. So recall that solving quadratic equations means that if the left side of the equation is ax squared plus bx plus c equals 0, it can be factored. So if this left side can be factored, then the equation can be solved by using the zero product property. And the zero product property, or ZPP, simply means that you would set each parenthesis equal to 0 and then solve for x. So think about how this property would be used to find the roots of an equation. So remember that roots and x-intercepts and zeros and solutions, they all mean the same thing. So what you're going to say is we would set the parentheses equal to 0 and solve for x. Every single problem that we will have in this lesson is going to have different directions. But even though they have different directions, the steps are going to be identical each time. And that's because x, or the roots, solving for x means that we are looking for the roots of the equation. We are looking for the zeros of the function. We are looking for the x-intercepts of the graph. We are looking for the solutions to the problem. All of these words mean exactly the same thing, and the steps are identical. You need to get your equation to equal 0, factor, and solve. Every single problem is identical. So example number 1 says, find the roots of the equation by factoring. So looking at our very first problem, we have x squared minus 2x minus 15. So I'm going to break this apart into two parentheses. I like this one because my a value is 1. I'm simply going to split this apart into an x and ask myself, what two numbers multiply to equal negative 15 but together add to equal negative 2? And that's a minus 5 and a plus 3. So therefore we set each parenthesis equal to 0. X minus 5 would equal 0, and x plus 3 would equal 0. I add 5 to both sides to find x equals 5, and I would subtract 3 on both sides to get x equals negative 3. These two numbers are the roots of the equation. This step right here of setting each parenthesis equal to 0, you don't have to show that step because a lot of us might be able to do this work in our heads, but if you need to show it, that's perfectly fine. The next one, this equation is not equal to 0, so that means that we need to bring 21 to the other side so that it is equal to 0. That way we end up with 2x squared minus x minus 21 equals 0. Cool, now I'm going to break this apart into two parentheses. Splitting apart, I like this one because we have a 2x squared. It splits apart into a 2x and an x. And now I've got to figure out what two numbers multiply together to equal 2, multiply together to equal 21, which I would think of 3 and 7, and together would get me the goal of negative 1, which is my b value. All right. So analyzing these numbers, I'm going to go 2 times 3 to get 6 and 1 times 7 to get 7. Can I get a negative 1 from 6 and 7? Yes. If I go 6 minus 7, I'll end up with a negative 1. So how did I get 6? I multiplied 2, which is 2x, which is on the outside, times a positive 3 that's going to be on the outside. I multiply, how did I get a 7? Well, I multiplied 1x times a minus 7. Now I'm going to set each parenthesis equal to 0. So we have 2x minus 7 equals 0 and x plus 3 equals 0. I'm going to add 7 to both sides to end up with 2x equals 7 and divide both sides by 2 to end up with x equals 7 over 2 or 3.5. I'm going to subtract 3 on both sides and I end up with x equals negative 3. So both solutions are perfectly acceptable. I'm okay with you working with decimals if the decimals are going to be numbers that are smaller. Oh, I'm sorry, excuse me. If the decimals are a terminating decimal, those tend to be easier to work with. Let's go ahead and look at letter C. Oh, I like this one. That's because this one has only 2 terms, and I noticed that the first term is a perfect square and my last term is a perfect square. And so because my first and last terms are perfect squares and they're being subtracted, this is a dots. So I know that this is going to be factored into a 4x plus 5 times a 4x minus 5 equals 0. Notice that all of my equations, I have maintained the equal 0. I need you to do the same. If you're forgetting that equals 0, you might lose out on some points and you really don't want to do this. So I can anticipate that if I were to set each parenthesis equal to 0, I would subtract 5 and then divide by 4, so that would be negative 5/4. Or I would add 5 and then divide by 4, so that would be a positive 5/4. That's me skipping a step and doing that work in my head. If that's too much for you, go back and show work. Get the right answer. It doesn't matter. I was just showing a way for you to not show as many steps. I know that there are kids in this class that always are looking for shortcuts. Another way you can write this answer is x equals plus or minus 5/4. Plus or minus is a plus sign and a minus sign underneath. And so that's just two different ways of writing your answer. I'm going to put a big fat or right there because you can work with one or the other. All right, the next 4 problems are team, pair, solo. That means I would like you guys to complete those problems on your own and be ready to discuss the next time I see you in class and be ready to discuss with the people sitting around you. Now, please note that solutions to a quadratic equation can also be referred to as roots. They are also the zeros and the x-intercepts of the corresponding quadratic function. So this is a recap of what we've already talked about before. So far the directions were find the roots. Now the directions are going to say find the zeros of the function. If they're asking you to find the zeros of the function, we are going to be using the same exact steps as before. The only difference is that for like example number 2, we have f of x equals, and because we want zeros, we're going to change this to 0 equals 2x squared plus 4x minus 30. Now looking at this problem, I notice that I have a 2x squared, a 4x, and a 30. And all of these numbers are even numbers. So that tells me that they have a greatest common factor of 2. And I recommend strongly identifying those greatest common factors before you start these problems because it will save you so much time. Look at that. We end up with x squared plus 2x minus 15. And that's a lot easier of a problem to factor. So I'm going to break apart the x squared into an x and an x, and I'm going to ask myself, what 2 numbers multiply together to equal negative 15, but together add to equal positive 2? And whenever I think of 15, I think of 3 and 5. And so if I had a positive 5 and a negative 3, they would together add to equal positive 2. So I'm going to set each piece that contains a variable equal to 0. And when I do that, I end up with the solutions of x equals negative 5 or x equals 3. And those 2 numbers are my zeros to the function. If they had asked you for x-intercepts, we would write this answer differently. We would write this answer as negative 5, 0 and 3, 0. So just note that if the question is asking you for zeros, you would write it just like we did up here for finding roots. But if they asked you to find x-intercepts, you'd need to take it to the next level and write them as ordered pairs. Please go ahead and try the next solo problem on your own and have that ready to go for the next time I see you in class. The next two problems, although they are a team and a solo, for this video lesson, I'm going to show you how to do those in the lesson. So here we go. It says you have a rectangular vegetable garden in your backyard that measures 15 feet by 10 feet. So I would strongly recommend drawing this picture. You have a vegetable garden that is 15 feet by 10 feet. All right, cool. And it's rectangular, so that means that we have ourselves a right angle. You want to double the area of the garden by adding the same distance x to both the length and the width of the garden. So what does that look like? We are going to be adding the same distance, and we don't know what that is, so we're going to call it x, to the length and the width. And that's going to create a new rectangular garden. So this length down here used to be 15, and then we added some x to it. So I'm just kind of like, that full length right here was to 15 and then x. What we want to do is we want to find the value of x and then the new dimensions of the garden. So let's go ahead and think about what was happening here. We want to double the area. What was the area before? Well, 100 times 15 is 150 square feet. And we want to double it with our new dimensions. So we want this new area to have a doubled area than what we had before. So 150 times 2 is 300. And 300 is equal to our new length times our new width. Our new length in this case is going to be 10 plus x, or in other words, x plus 10. And our new width is going to be 15 plus x, or in other words, x plus 15. Cool. Let's go ahead and FOIL this and solve it for x. So I'm going to FOIL and get rid of the parentheses. So this is 300 equals x times x, which is x squared, x times 15, which is plus 15x, 10 times x, which is plus 10x, and 10 times 15, which is plus 150. Because this is a quadratic equation, it needs to equal 0, so I'm going to subtract 300 on both sides, and I'm going to combine my like terms. So I'm doing more than one step in one step. And when I do that, I'm going to end up with 0 is equal to x squared plus 25x minus 150. And now what I need to do is I need to factor this into two parentheses. I'm going to split apart the x squared into an x, and I have to think about the factors of 150 and see if any of those will get me 25. So what might be helpful is to write down those factors of 150. So if 150 divided by 2, that's 75, and that's not going to get me 25. So that's not going to work. 150 divided by 3, that is 50, and that's not going to work. 150 divided by 4 is going to be a decimal. 150 divided by 5, that is 30. Can I get a 25 from 5 and 30? Yeah, I can. If I were to go positive 30 and a minus 5, that's going to get me a 25. So I need a plus 30 in one of my parentheses and a minus 5 in my other parentheses, which means that if I were to solve this equation, I would have two solutions. I would have x is equal to negative 30, or I would have x is equal to 5. Now, we're talking about length. So would x equal negative 30 make sense in this problem? No, it would not. We cannot have negative length. So that tells me that x equals 5 is the value of x that I'm going to be working with. Cool. I just found what x is equal to. Now I need to find my new dimensions of the garden. So my new length is going to be equal to, I want to say that it was, well, I want to say that I had my length being 15 plus x. Maybe I had it the other way, and that's okay. So that's going to be 15 plus 5, which is going to be equal to 20 feet, keeping my units. And my new width, that's going to be equal to 10 plus 5, which is 15 feet. Now, if you flip-flop those, it's perfectly fine. Just as long as you have those numbers of 5, 20, and 20 feet and 15 feet, you're totally fine with that. I would like you to please go ahead and try the solo problem on your own and have that ready to go for the next time that I see you. Let's go ahead and look at example number 3. It says an internet provider sells internet service for $30 per month to 1,500 customers. For each $1 increase in price, the number of customers decreases by 25. Now, this is one of those revenue questions, and I love these revenue questions because they are a true application of solving quadratic equations. So remember that x always represents the number of price increases or decreases. It's how many times the price changes. And R of x represents your timely, whatever, monthly, daily, yearly revenue. So in this problem, we're going to let x equal, well, it looks like the price is increasing. So we're going to let x equal the number of price increases. And it's very important that you label and identify what your variables are before you get started with these types of problems. R of x is going to equal, well, it looks like we want to find, it looks like $30 per month. So this has to be monthly revenue. And whenever we are working with revenue, we're always talking about price as it compares to quantity. So I'm going to write this as R of x equals, let's talk about price. What it starts off being goes first. And what it started off being was $30 per month. And the price is increasing by $1 each time. If it was $5, that would be plus 5x. And that's dealing with money. Customers is your quantity. They will start off with 1,500 customers, but because the price is going up, people are saying, no thanks, I'll go someplace else. And it decreases by 25, so minus 25, every time the price increases. So one deals with price and the other one is dealing with quantity or number of customers. Question letter A says, how much should the company charge in order to maximize revenue? So whenever you want to maximize revenue, that means that we want to find what the x part of, or the y part of the vertex is. So that means that we get to use our skill of finding our zeros or finding our roots or finding our x-intercepts to help us identify that the x part of the vertex to help us find the y part of the vertex. So I'm going to make this equation equal 0, and I'm going to rewrite it as 30 plus x times 1,500 minus 25x. And so because we're finding zeros, I'm going to set each parenthesis equal to 0. 30 plus x equals 0, and 1,500 minus 25x equals 0. So we want to figure out how much they should charge. So that's going to be where we want to find the x part of the vertex, and then we want to maximize. And I think that the maximize question is going to be down here where we'll need to find the y part. So we don't really need to find the y part. In this one, we want to actually analyze that parenthesis dealing with the money. So this parenthesis is really what our focus is. But because it's the maximize, we really are interested in the x part of the vertex to help us find that answer first. All right, so let's go ahead and find that x part. I'm going to subtract 30 on both sides, and we end up with x equals negative 30. Over here, I'm going to add 25x, so we end up with 1,500 equals 25x. Dividing both sides by 25. This is where you would probably want to use a calculator. 1,500 divided by 25, that is 60. So we find that 60 is equal to x. So now, in order for us to find the x part of our vertex, we need to average our x-intercepts. That's negative 30 plus 60 divided by 2. That is going to be 30 divided by 2, which is 15. So the x part of our vertex is 15, and we're going to use that 15 to find how much the company should charge in order to maximize revenue. So if we're just looking at how much they should charge, that is 30 plus 15. And 30 plus 15, that is 45. And in this case, in terms of money, $45. In words, whenever you have a story problem, always give your answer in words. And that is the company should charge $45 per month for internet service. To maximize revenue. Cool. So that is our first answer. Now let's go ahead and find out what that maximum monthly revenue actually is. So going back to working with our vertex x, of being 15, I'm going to go R of 15 is equal to 30 plus 15 times 1,500 minus 25 times 15. So R of 15 is going to be equal to 30 plus 15, that is 45, and 1,500 minus 25 times 15 is $1,125. If I were to multiply those two numbers together, I would end up with $50,625. So that means that if the company charges $45 for service per month, it will reach the maximum monthly revenue will be $50,625, and that's if they charge $45 per month for internet service. And that is the end of today's lesson. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.